Welcome to Excel Business Statistical Analysis video number 3, where we get an introduction to worksheet formulas. On the topics worksheet, this is video number 3 for chapter 1. We'll cover worksheet formula elements, worksheet formula models, types of worksheet formulas, and percent formulas. Now let's come over and right-click the sheet scroll arrows to open up the Activate dialog box. We'll select Formula Element Sheet and click OK. That jumps us to the sheet where we're going to start our work. Now, this is a reference for you. You can come back to this later or read through it. We will see all these elements as we build our formulas. But some of the things we can put into formulas, equal signs, cell references and table references, math operators, numbers if they don't change, like the number 12 for number of months in a year. We can have built-in functions like sum, countifs, norm.dist, and many others. Comparative operators, greater than, less than. The join symbol, ampersand, and even text if we put it in double quotes. Now here's the math operators presented in the math order of operations. Now comparative operators, we'll use a lot of them in this statistics class. Now the only difference is from math, we do not have a single character for greater than or equal to or less than or equal to. You type 2 characters, one after the other, and we'll see many examples of that. Now, sometimes we're going to have to join things together. For example, you might have to join greater than or equal to comparative operator to a lower limit to count everything above that limit. And then your order of operations, that's parentheses, exponents, multiplying and dividing, adding and subtracting. Excel knows those math order of operations, but there's some other things it has to consider when calculating a formula. For example, it needs to evaluate the colon to get all the numbers between those 2 cell references, or comma. Those are called reference operators. And negation, if you put a minus sign in front of a number, Excel considers it a negative number. And a percentage is always evaluated to the actual number before the calculation is made. So parentheses and then these, math order of operations, and the last 2 things that are calculated in this order, ampersand second to last, and then comparative operators. Now, usually we don't have to think about these, but occasionally, if you run into a formula that's not calculating correctly, you can consult this. Now, after looking through this list, I want you to recognize that an equal sign happens in 2 locations. We can have an equal sign as the first character in the cell, and that's for us to tell Excel that we're making a formula. Down here, we will use the equal sign as a comparative operator, but that's only when the equal sign is not the first character in the cell. That's when you're asking the question, are 2 things equal? Now let's go over and look at worksheet formula models. Now the first thing to consider in a worksheet formula model is the worksheet formula, and that's just a tool to make calculations and perform data analysis. Now, when you're using worksheet formulas to build a model, you have to consider number formatting as a facade, Excel's golden rule, whether or not you want to document your formula, and sometimes you have to use the round function because number formatting will not do it for you. Now, before we build a small worksheet model from scratch, we want to consider number formatting as a facade. So as an example, here's some numbers. We have 2 columns. Let's come down here and use our keyboard Alt equals to invoke the sum function. I see the range is correct, so I hit Enter. 21. I'm going to come over here, Alt equals, and Enter. 19. Well, wait a second. 4, 3, 5, 4, 3. Those are the same numbers. How could an Excel formula make an error like this? Well, the formulas did not make the error. The source of the difference in these numbers is because when you click in the cell D16 and look up to the formula bar, the actual number in the cell is 4.49. But it's being displayed using number formatting as the number 4. If I select E16, here I can see the actual number in the cell is 4, and the displayed number is 4. if we select all the cells using our selection cursor and go up to the Home Ribbon tab, Number Group, and increase the decimals, we could see the source of the problem. There was a bunch of decimals that were not being displayed. Once we increased the decimals, we could see here was a column of integers getting the correct total of 19. But here we had the integers, but we had a bunch of extra decimals. And that sum function, if we F2, it added all of the integer parts, but also all the decimals, even though they were not displayed. So when you're building a worksheet formula model, this is how you want to display the numbers. That way it's not misleading. If you decrease the decimals, that is misleading. Now we have the same column of misleading numbers over here, but rather than using the increase decimal button, we can use from the number formatting dropdown, the general number formatting. Now there's a bunch of great number formats we can add, but the general number formatting is like an eraser. It'll wipe away all number formatting and show you exactly what's in the cell. So let's apply the general number formatting. Now let's click in H21 and use our keyboard to add Alt equals. And when I hit Enter, I forgot to change the number formatting on the total cell. Now I'm going to select the cell, and instead of going up to the dropdown and selecting General, because General is such a useful number formatting, let's use the keyboard. Now you're going to have to find the key to the left of the number 1, tilde, grave accent. And you're going to have to hold down Control Shift and tilde at the same time. Control Shift tilde or grave accent. So in a worksheet formula model, this is how you want to display the numbers. But what if you actually wanted to round? You cannot use number formatting to round. Now watch what happens up here and on the surface of the spreadsheet with number formatting when I decrease the decimal. Notice the number didn't change, so we did not round it. We displayed it differently. Now I'm going to Control ZZ to undo that. If we actually want to change the number, that's where the worksheet function round comes in. Now, if we want to do a formula, the first character in the cell is an equal sign, and there's no keyboard shortcut for any function except for sum, so we have to type it out. And the name of the function is round. And when I type ROU, I can see a drop-down. And the function highlighted in blue shows a screen tip. And actually, you can down arrow and read each one of the screen tips if you're not sure which function to use. But rounds a number to a specified number of digits. That sounds like what we want. Now, when the function is highlighted in blue, you can use your tab key to enter the function into the formula. Now, this function has two arguments, number and number of digits. So to get it to work, you got to put in some number to round. And then for number of digits, you have to tell it the position you want to round to. All right, so the number argument is bold, and that's the round function saying, hey, I need a number to round. So we'll put the number we want to round into the number argument. I'm going to take my cursor and click on cell H19. Now the screen tip is helpful. It reminds you that in order to get to the next argument and enter it, you have to type a comma. Now watch what happens when I type a comma. It's polite. The number of digits argument is bold. That tells you that you have to enter number of digits. Now I have a diagram here to help you figure out what you have to put in number of digits. Now here's the way I remember it. I just count from the decimal, moving to the right, 1, 2. If I were rounding to the penny, I'd put a 2 into number of digits, which is what it says right here. And if I want to go the other direction, 2, 1, 0. So if I'm rounding to the ones position or the dollars position, I have to put a 0. That's what it says right here. When you're rounding to a position to the right of the decimal, you count 1, 2, 3, 4, and however far you want to go. If you're moving to the left, you count backwards, 0, -1, -2, -3, and so on. All right, so we're going to put a 0 here. And when we close parentheses and Control Enter, now we have rounded the number. We didn't use number formatting. We used the round function. Now, I want to hit the F2 key and look at this. H16 is a relative cell reference. That means if I were to copy this formula down, it's not going to be locked on H16. It's actually going to move relative to the formula. So right here, it's looking 1, 2 cells to the left. When I copy it down here, it's not going to be still looking at H16. It's going to be looking at 1, 2 cells to the left. So now I'm going to Control Enter. And in the lower right-hand corner, that little green box is called the fill handle. And that fill handle does a lot of magic things. Now, right now, I see my selection cursor. If you hover over the edge of the cell, the cursor changes. That's not the cursor we want. That's the move cursor. The cursor that you want, and sometimes it's hard to get. See, oh, I can't quite get it. There it is. Now, Microsoft calls this the crosshair. I like to call it the angry rabbit. If you click, left click, and drag down, you are copying the formula. When you let go, we've copied the formula down. Now, anytime you copy a formula down, you have to go to the last cell and hit the F2 key. When you hit F2, you're verifying that the cell reference is looking at the right location. And sure enough, it is. It's looking 1, 2 cells to the left. It took 3.44 and rounded to the ones position. So when I hit Enter and Alt equals and Enter, now I have officially taken some numbers, rounded them, and added them. So the moral of the story here is number formatting is a facade. It only displays the number in a certain way. Formulas do not see number formatting. If you officially want to round, then you have to use the round function. Now, the next topic when it comes to building models in the worksheet is Excel's golden rule. And here it is. If a formula input can change, put it in a cell, label it, and refer to it in the formula with a reference. However, if a formula input will not change, you can type it into a formula like 12 months in a year, 24 hours in a day, or 1 to represent the base amount in a percentage formula. Now, let's use these guidelines and put them into action and build a small model. In the last statistics class, 5 out of 62 earned an A grade. Using this past data, estimate the chance, the probability, that a student will get an A in the current class. Build a model that allows you to change the formula inputs and which is well documented. Now, I'm going to type past data to indicate that this is the relative frequency method of calculating probability. We actually won't learn that term until Chapter 4. Now, I did a little trickery there while I was talking. I did Control-Enter, Control-B, and then Enter. And Excel's golden rule says the formula inputs, looks like the numerator 5 and the denominator 62. Those have to end up in cells so we can build a formula and refer to them, but we got to label them too. I'm going to hit Tab, type a 5, and then Enter. Come up and in between C and D, I see my change the column width cursor. I'm going to click and drag. And then down here, type total students, Tab, 62, and Enter. I'll type the name of the calculation, Tab. Now I'm going to make the formula here, and I've entered labels and the formula inputs. Now I want to add some style formatting like fill color and font color. I'll select the range, go up to the Home Ribbon tab, and there's some buttons up here, but you can also right-click, and a lot of the things are on the mini toolbar. I'm going to click the drop-down and select all borders. Select these 2 cells, right-click, and for fill, I'll do red. Font, I'll do white. Right here, right-click, some dark blue, and some white font. Right-click. And the green that I want, I already have it here, but if you want to use the same green that I use, you have to go down to More Colors. And it's this one right here. Reminds me of the accounting paper I used to use before Excel. Click OK. Now I want to compare these 2 numbers using division. So I type in equal sign. Remember, an equal sign is always the first character, and it tells Excel that we're making a formula. Now I could take my cursor and click on the numerator, but if you're building a formula and the formula inputs are close, it's faster to use your arrow keys. up arrow, up arrow. And the great thing is if you make a mistake, you just keep using your arrows until you get the cell that you want, / for division, and then up arrow, and enter. Now I want to come over to F32 and type formula, because it said to document it. Control-Enter, Control-B. And down here, we could just use Formula Text, Tab. If I click on a cell that contains a formula, close parentheses and enter, it'll show me the formula. Now, the problem with this is if I want to copy it down because I'm anticipating that I'm going to make some more formulas down here, I get an NA. If I select the cell and hit F2, because there's no formula in D36, formula text is polite. It says not available, or NA. So I'm going to click the escape key, come up to this cell, and hit F2. There's a great function called if NA, tab. Now we have a function within a function, but in the value argument, that's what I'm trying to calculate. But sometimes it gives me an NA. So I come to the end very carefully and click. The screen tip reminds me that I type a comma to get to the next argument, and value if NA. Now, I don't want to show anything. I could put something like in double quotes, no formula, end double quotes. Now I'm going to close parentheses, Control-Enter, and I'm going to copy it down. But I don't want to do that. Maybe you want to do that. In the top cell, F2, I'm actually going to get rid of all of the text, but leave the double quote, double quote. So I highlight and use the delete key. Double quote, with nothing between the quotes is the syntax we use in a formula to show nothing. Now, technically, it is something. Because it's double quotes, it's text. And because there's nothing there, it's called a zero-length text string. Control-Enter, and copy it down. Now, I want to create another formula right here. And guess what? I already did a bunch of formatting. I have borders and green and blue fill and white font. If I want to copy just the formatting and paste it down here, I can do that. With the formatting selected that I want to copy, come up to the Home Ribbon tab, Clipboard, and Format Painter button, or right-click, and there it is. When I click this, my cursor is loaded with a paintbrush. That means when I click somewhere, it's going to paste just the formatting. Now, I need to do this carefully because if I click in the wrong place, it obeyed me. It put it there. Control-Z. I'll reload my cursor with the formatting. And now very carefully in C37, I click, and the formatting is applied. I'm going to type a label. Now I want to do tab, equal sign. And all I'm going to do is pull that number down here and enter. Now, I want to add number formatting because I want to see it as a percentage. Now, in our previous example, we were allowed to look up into the formula bar. And when we added number formatting, we could see the actual number. But this is a formula. And so we can't actually see the number. But let's apply the number formatting. I want to come to the drop-down and select percentage. Now, when you select from the drop-down, this will give us percentage number formatting with 2 decimals showing. And that's what I want. So that's 8.06% that a random student selected has the chance of getting an A. Now, notice the number is still there, even though we can't see it. Down here, I'm referring to it. And all of those messy decimals are still under there, even though I'm displaying it with a percentage number formatting. All right, so as you work through this class, you want to follow these rules when creating formula solutions in the worksheet. Now, we want to go over and look at the different types of formulas. Now, formulas by data type. That means what does the formula deliver? We can have a number formula because it delivers a number, time, or date. A text formula because it delivers a text result. Or a logical formula, also called a Boolean formula. These formulas deliver true or false. Now, formulas by calculation type. We have aggregate formulas. These operate on an array of values and deliver a single answer, like adding, average, and an AND logical test. The second type of formula a single input output formula. These are formulas that operate on single inputs and deliver a single answer. Think of our formula, text formula we just did. We pointed to a single cell, and the function delivered a single answer. There are also array formulas. These are formulas that contain one or more array operation that deliver an array of answers rather than a single answer. So if we look at the formula text function, if we put not a single cell, but a range of cells into the function, that's an array operation, and the function will deliver an array of answers. Now, there are two types of array formulas, and they both have internally in the formula an array operation that delivers multiple answers. But the difference between these two is a dynamic spilled array formula spills an array of results into the worksheet, and a scalar array formula takes the array of results and does something like aggregate to deliver a single answer. Now, dynamic spilled array formulas are only in Microsoft 365. If you happen to have Excel 2021, some of the dynamic spilled array formula capabilities are in that version. Now, if you're a Highline student, you automatically get a free copy of Microsoft 365 from the college. Now, let's go over to the sheet formula type examples and look at an example of each of these. Now, let's scroll down, and we're going to start off multiplying units times price. And that would make this a number formula since it's delivering a number. And we have two single inputs, and the formula delivers a single output. So we're going to make our formula equal sign left arrow times left arrow. Now, I want to put the formula in the cell and move the cursor up so I can use Shift-Enter. Now I want to label. So I'm going to type sales and indicate the unit dollar in parentheses. In the label at the top, Control-Enter. But now I want to make a text formula. So F2, and at the very beginning, I'm going to type an equal sign because that's how you start a formula. And I'm going to put sales in double quotes. But right at the end, I'm going to be sure and type a space. And then double quotes. Now, if that was the formula right there, that would be silly. But now I'm going to join it. That's called the ampersand. It's the join operator. There's one thing on the left. That means some text. And now I'm going to click on B13. That has the number 5 right now. Now, let's just see what this gives us. Because so far, the join operator is just joining 1, 2 things. Control-Enter. Now, if I change this to 6, that's what's so cool about this text formula. Now we're going to have a label at the top that can show us the calculation. So up here, F2. And what I really want is I want sales equal to, and then we'll show the calculation. So right before the double quotes, I'm going to type an equal sign and then a space. And then with my I-beam cursor, I'm going to join a third thing. Now I want to show the multiplication operator. So in double quotes, I'll type a space, multiplication operator, space, end double quote. And now I want to join that third thing to a fourth thing. Now I'll click on the price. And when I Control-Enter, now I have something looking pretty cool. If I change this back to 5, bam, the label updates and the number calculation. Now, of course, this is a text formula, and there's single inputs and single outputs. Now, down here, we want to try a logical formula to give us a true or false. And this will also be single input output formula. Equal sign, and then I'm going to use left arrow to get your GPA. And I want to ask the question of your GPA, is it greater than or equal to? That's two separate characters. There's no greater than or equal to single symbol in Excel. And then left arrow. So this logical test is asking, is your GPA greater than or equal to the required GPA? When I Control-Enter, I get a true. If the required GPA becomes 3.9, I get a false. 3.75, it better be true because F2, I have that equal sign there. And Enter. Now, our next calculation, we're going to calculate the average or the mean. So there'll be a number result, and this is an aggregate formula. We're going from an array of values to a single answer. Equals, and there's no keyboard for average, so we type AV. Wow, and look at that. There's a bunch of different averaging functions, but the one we want is called average. It says returns the average arithmetic mean of its arguments, which is what we want, so we hit Tab. Now, the number argument means give me some numbers, and you can put multiple ranges or single values separated by commas. We're simply going to highlight those 4 numbers. And here's a cool trick. We're supposed to put a closed parentheses, but on a simple formula like this, if you leave it out and hit Enter, it automatically puts it in. And you can see it over here. Now, in statistics, these are called observations. So we had 4 students, and we observed their scores. And many times, we're going to have to count how many observations there are. If we have a column of numbers, then we can use the count function. This function counts numbers. Now, the count function has value 1, value 2 as its arguments. When we used average, it said number 1, number 2. For both of these aggregate functions and all the other aggregate functions like sum, COUNTA, max, min, rows, standard deviation, and others, they all have arguments where you're allowed to enter multiple ranges or single values separated by a comma. In our case, for value 1, we only have a range of 4 values. I don't have to put that closed parentheses. I hit Enter. Well, I thought I was going to make a formula here, but now I have to go back up here because I definitely don't want the currency number formatting. And this happens all the time. The cell has been pre-formatted. You can look up to the number group, and if it's a built-in number formatting, you'll see the name listed in the drop-down. Now, I'm going to use my keyboard to apply the general number formatting, Control-Shift-tilde. Remember, general number formatting is like your eraser. It wipes away all the number formatting so you can see the actual number. Now I'm going to hit Enter. And sometimes we're not given a column of numbers. We're given a column of text values. And oftentimes people use the COUNTA function. Now the COUNTA function counts the number of cells in the range that are not empty. That means it'll count numbers, text, zero-length text strings, anything, Tab. But it's often used for text data. And Enter. Oh, that one has some rogue number formatting too, Control-Shift-tilde. Now I paused the video and added a new row here because there is another way to count observations. Now, if you want to count from a column and there's an empty cell, and you actually want to count how many rows there are, you can use the rows function. It simply looks at a column, a table, whatever the range is, and it only counts the number of rows. So here it'll count 4. Now I'm going to add this student back in using my angry rabbit. There's a word and a number, so when I copy it, it increments the number. Now let's scroll down, and we want to talk about an amazing feature in Microsoft 365 Excel. Now in Chapter 3, we'll talk about the mean, which is adding them up and dividing by the count. And the reason that we calculate the mean is so that we have one number that represents all the data points. Instead of telling someone, hey, the scores in the class were 87.5, 79.5, and so on, you use a single number to represent all the data points, and you say the average score was 81.73. Now in Chapter 3, we'll learn how to calculate or measure how reliable this mean is. And in one of the calculations, we'll have to calculate the deviations. That just means take each particular value and subtract the mean. That'll tell us how far the particular value is from the mean. Now, I'm going to show you the old school way to do this formula and then the new school. New school meaning Microsoft 365 dynamic spilled array formulas. All right, so equals the particular value. And we know if we copy this formula down, that's a relative cell reference. So it'll move. In each row, it'll always see one cell to the left. But I need to subtract the same average in every single cell. Now, right now, if I Control Enter and copy this down, go to the last cell and hit F2, which means you're verifying that the cell references are looking in the right place. And they definitely are not. And that's because when we entered the cell up here, the orange cell was a relative cell reference that was looking 1, 2, 3, 4, 5, 6 cells above. So I'm going to Escape and Control Z, Z. And we're going to make the formula again. Equals relative cell reference, the score directly to the left, minus, and I'm going to go get my mean. And when I hit the F4 key, the F4 key puts the dollar signs in. There's a dollar sign in front of the column reference D and in front of the row reference 24. And they are the way that we lock the cell reference. Now, those dollar signs don't mean dollar or anything. That's just an arbitrary symbol that the people who invented the spreadsheet used to say this cell reference can no longer move when we copy. So Control Enter and copy it down. Go to the last cell and hit F2. And here, when we verify, we see there is no mistake. Right? So in the old school method for making a calculation like this, which was common, you could imagine another scenario where we had sales and this was a tax rate. But it's always been common that we need in our formula one relative cell reference and a cell reference lock. But that's the old school. Here's the new school Microsoft 365 way. Instead of clicking on one relative cell reference, you select all the cells that were going to be relative cell references. Then you subtract the mean. And now we're making an array calculation. It's no longer a single item on either side of the operator. That's an array of items. And when you take an array of items and you subtract a single item, the formula will take each one of these 4 different items, and from each one of those items, it will subtract the mean. Now, in Microsoft 365 Excel, when you have an array formula like this and you hit Enter, the results spill into the worksheet. If you do not have Microsoft 365, you will get a value error. Then you have to do it the old school method. Now, very importantly, when we spilled that result, I want you to look up to the formula bar. Every cell below the top cell is grayed out. The formula only lives in the top cell. Now, there are 3 amazing advantages to this type of formula over this type of formula. And they are, we didn't have to lock the reference. We didn't have to copy the formula. And if you need to edit later, you only come to the top cell and edit, and it automatically spills the edited formula. For example, in Chapter 3, we're going to have to take these deviations and square them. So here it is. I'm in the top cell. We have to force subtraction to occur before an exponent. And an exponent in Excel is caret, shift 6, and then 2. Now when I hit Enter, the results automatically spill. But look what we have to do up here, F2. When we want to edit, we have to go to the same top cell. We make our edit. But then we have to Control Enter and copy it down. So with a formula like this, we don't have to worry about locking. We don't have to copy. And editing is easier. Now I'm going to hit Enter. Now this is a number formula, and it has a single input-output. But down here, well, it's still a number formula, but this is a dynamic spilled array formula. Now, before we look at the other type of array formula, I want to go back over to the sheet, Worksheet Formula Models. Now, we did the round function, and we copied it down. But since we know that in Microsoft 365, we don't have to copy, we can redo this formula, highlighting all the potential relative cell references, because we've highlighted 5 different items. And into the number argument, we put an array of 5 items. We're making a function argument array operation, comma, 0, close parentheses. And when I hit Enter, the 5 results spill into the worksheet. Now when we come to the bottom and Alt equals to add the results, we don't get a range from N16 to N20. We get only the top cell because that's where the formula lives. That hashtag or pound symbol, that's called the spilled range operator. And what it says is, please get everything that spills from cell N16. Now let's go back over to the Sheet tab Formula Types example. Now when we have a dynamic spilled array formula, that means that the last calculation generates a number of values that spill into the worksheet. But sometimes we have an array calculation like this, and then we want to aggregate it. So if we scroll down here, now in Chapter 5, we'll have this discrete variable probability distribution. And from this distribution, we're going to be required to calculate the population standard deviation. And that means taking the data here and making all sorts of intermediate calculations to then sum and take the square root. Now the only number we're interested in is the final number. These are all just extra numbers sitting in the spreadsheet. Well, guess what? With a scalar array formula, I can take all those calculations and in a single cell formula, make the calculation. Now, if we go inside of the sum function and click on number 1 and hit the F9 key, that's an array calculation that's delivering an array of answers. But it's inside an aggregate function, sum and square root, so it takes the result of the array operation and delivers a single answer. This is a scalar array formula. And the beauty of formulas like this is that we don't have to do all these intermediate steps, and we don't have to waste all this spreadsheet real estate. Next, we want to go over to the sheet called Excel table. Now we want to talk about what an Excel table is. We have 1, 2 tables that are just sitting in the worksheet, but this is a special type of object called an Excel table. And if we look up to table designs, it has a certain formatting and it has a name. And formulas work differently in Excel tables. Now the reason that people store data in Excel tables is because if you add extra rows or columns, anything pointing to this table will update. So if you have a formula or a pivot table or a chart pointing to this table, if you add new data, they all can be updated with the new data. That does not happen when you have tables like these. Now in all 3 tables, I want to calculate the tax amount. That means each sales value times a tax rate. So we have messy decimals here, so we're going to use the round function. And we'll do this the single input output way, relative cell reference times the tax rate locked with the F4 key, comma. And here we're dealing with money, and we need to round to the penny, so we put a 2. Control Enter, copy it down, go to the last cell, and hit F2. Cell references are working. If we're using dynamic spilled array formulas, we highlight all the sales values times the tax rate, comma 2, close parentheses, and it spills. Now the way the formula is going to work in this table is half like this formula and half like this formula. And it's going to not use cell references, but table references. Now, table design, that's the name of the table. If I were to build a formula, Alt equals, and I highlight the entire sales column with my black downward pointing arrow, notice it puts the table name and then the field name in square brackets. And that's dynamic. If I start adding new rows down here, that automatically updates. Now let's make an Excel table column formula. That's where it's going to be half like this formula and half like that formula. Equals round. And because it's in the column, when I click on a relative cell reference, it can't put the whole field name in square brackets because then it would get everything. But that @ symbol is called the implicit intersection operator. But it really just means, hey, I'm going to act like a relative cell reference. So as the formula is automatically copied down, it'll get the sales value for the given row times. And we have to click on the tax rate. And guess what? It's outside the table, so we have to hit the F4 key to lock it. That's what makes it like the single input output formula. But then, comma 2 close parentheses, it's like the dynamic spilled array formula because in an Excel table, when I hit enter, it automatically copies down. If I look at the last cell and hit F2, the @ symbol says, hey, get whatever's in the sales column in this row. Next, let's go to percent formulas. Now on this sheet, we want to look at two different percentage calculations. The first one is we have a set of counts or frequencies. So we have a count of 2, 21, 42. And all of those counts add up to 100. We would like to compare each part to the whole. Now when we do this based on past data to calculate a probability, it's called a relative frequency. But we know it as simply, hey, take the part as a relative cell reference, divided by the total, F4, Control Enter, copy it down, click in the last cell, Alt equals. Now that's the old school method, but it gets it done. Now we could add number formatting to these if you want. Control 1, Format Cells dialog box, Number tab, percentage, 2 decimals, click OK. If we have Microsoft 365 Excel, it's probably easier to just highlight all the counts, divide by the total, hit Enter, and uh-oh, I made an error. No worries. I come up to the top cell, F2 to put it into edit mode. I'm going to highlight the equal sign, type divide, and Enter. Come to the bottom, Alt equals. We got the top cell and our spilled range operator, and Enter. So here we're comparing the parts to the whole. Down here is a different situation. We have a start or a begin amount and an end amount. And we want to calculate the percentage change. Now the way you were probably taught in school is in the numerator, in parentheses, you calculate the change. N minus begin, close parentheses, and then you divide by the start. Now this will always give you the right answer, tab. But a faster way to do this is equals end amount divided by the start amount, and you subtract 1. It's easier because it's fewer keystrokes, and it will always give you the same answer. Now, why is that true? Well, if we have the change amount, n minus begin, and notice that's subtraction, and we have a denominator, well, we can break it apart. End over begin, bam, we put the operator. Begin over begin, anything divided by itself is 1. So we get end divided by begin minus 1. Man, that was a lot of fun with building worksheet formula models. We talked about percentage formulas. We talked about the different types of formulas. We also looked at important guidelines for building worksheet formula models. And guess what? We started it off by looking at formula elements. And guess what? I put an extra sheet in here. This is from my upcoming book. This is a list of every single possible formula element and a description. All right, next video, we're going to talk about Power Query to import a CSV file, pivot tables to make tabular summaries, and Excel charts to visualize.